This is Josh White with JW Math Tutoring. In today's video, I'm going to cover 10 problems from the October 2025 Digital SAT Math Test. So let's go ahead and get started.
But life is a dream the calculus could never predict.
Before I start going through these questions from the October 2025 official SAT Math test problem worksheet number 1, I just want to mention a couple things that I do at the start of all these videos. First, if you like this video, please, of course, do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there is a link to this PDF file in both the description of the video and also in the pinned comment below. Third, I've changed the format of these videos a little bit in that I'm now primarily highlighting excuse me, new questions or questions that have maybe only been featured like once before in a previous video. So there's going to be two videos covering basically either brand new or relatively new questions. All of the what I call repeat questions, which are those that have been featured, previously, usually at least once or more, a lot of times more than once, are going to be in a separate video. And basically in that video, I'm just going to go through and kind of show the question or the type of question, and then it will say these are the specific videos or worksheets you should check out to see that question. Okay, so basically that way I'm not kind of like resolving the same question type, over and over and over again. You can go see, December 2024 worksheet number 1, problem 5, just as an example, to see how you solve, this specific type of problem, that I've already done, and maybe you got it on your October test. Okay. So anyways, the other thing I want to mention is, of course, these are all self-reported questions, so I've tried to make them as realistic as possible. Also, there might be some pieces of information that are missing. If you actually recognize a question here that you got on your exam in October. And also, there could be, related to that, some questions could be done as free response when, in fact, on the test they were multiple choice. So if a question was a multiple choice one with answers, then there could be alternate ways to solve it that I'm not going to cover because I'm solving it as a free response. So please keep that in mind. All right, so with all that being said, let's go ahead and get started on this October 2025 official problem test worksheet number 1. So the first question here is asking you to identify what type of function is described in the text. Now, you see 64% and you might automatically think, oh, it's going to be exponential because of the percentage. However, that is actually not the case. So, what's going on here is, if you go ahead and translate this, you have the function, say s of t, and then it is 64% of t less than t. So that means we're basically subtracting the 64% of t from t. Now, 64% of t is just the same as taking t and multiplying it by 0.64. So now you really have t minus 0.64t. Well, that just simplifies to 0.36t. Okay, so at this point, first of all, hopefully you recognize it's linear. Okay, it is not exponential, so we can get rid of these two. And it's also going to be increasing because this 0.36 out here, this is really the slope, and this is a positive number. Okay, therefore, this is going to be an increasing linear function. Note that the t is greater than 0 part. That technically doesn't really apply or isn't needed for linear functions, but you would need it for exponential functions. So that's just thrown in there to, in case it's like it would be an exponential function, but in this specific instance, it is not. So question number 1, the answer is A. It's increasing linear, and you could just go to Desmos and graph this out, and you can see it's just going to be, an increasing line with a positive slope increasing from left to right. All right, next question, number 2. So this problem, it was self-reported on Reddit, and the way the person said it had something that it was some type of inequality, but I went back and looked at it. I could not figure out exactly how to set it up to make it, such that it was an inequality and gave like the specific answer that was reported. So I'm just going to solve it as a system of equations and then, show you which one is closest uh, to the solution. So this person's going running and biking. It's a 3-hour period. So we have the amount of time running. We're going to call this running and this biking, and together they add up to 3 hours, right? And then we also know that the total distance covered was 25 miles. So my second equation is going to be the distance. So rate times time equals distance. It's a basic formula to know. Therefore, running 7.2 miles per hour times the amount of time spent running, which we've already said is x, plus 11.4 miles per hour multiplied by y, the amount of time spent biking, will together add up to 25, because these two expressions are both distances. All right, so now we can just go to Desmos, and basically just graph this out and see where they intersect to solve it. All right, so let's just go ahead. There's our first equation. There's our second equation. Okay, here's our intersection point. So solution comes out here, 2.19, 0.809. So I actually fooled with these answers a little bit because the self-reported answer that the individual, who originally posted this question said that he chose, or she chose, was like 0.9 something. So I just went ahead and changed it, down to 0.8 to make it a little closer. So the correct answer here would be B, just 0.8 hours. Again, the one thing that the individual mentioned is that there is some type of inequality, and that would mean that there's some type of like constraint on this. So I don't know exactly how it was worded or what it would be to make it such that like, the actual answer comes out as like 0.809, but because of the constraint, because of the inequality, you actually have to round it to 0.9, unless there's some other thing that you has to, I don't know, he has to run for a certain period of time, or he cannot run for over some period of time or something. But in any case, this is how you set up the system of equations, and you go ahead and solve it, and get the answer for the amount of time spent biking. All right, next up, we have a right triangle problem. So for this one, I'm just going to go ahead and I'm going to draw my diagram first. Notice that B is the right angle, so I'm going to put that down here in the corner. And then A versus C, it doesn't really matter. I'm going to put A at the top and I put C at the bottom. AC is the hypotenuse, which is 24. AB is a leg, which is 6. And you're told the area is equal to K cosine C. Okay, so area is equal to K and the cosine of angle C. Find the value of K. All right, so there's technically two different ways you could do this. The quickest or fastest way is to notice that, excuse me, the area of a triangle is also equal to 1/2 base times height. And since this is a right triangle, we have BC as our base and we have AB as our height. So 1/2 times BC times 6 is equal to K, and then the cosine of C is equal to the adjacent over hypotenuse. So the adjacent is also BC, and the hypotenuse is 24. So notice you don't even need to know what BC is because it's going to cancel out on both sides. And 1/2 of 6 is 3, and you get K over 24 equals 3, K equals 72. Okay, so that's the correct answer. That's what you would type in. Now, an alternate way to do this would be to find the actual values for C in degrees and the actual length of BC, and then plug all those in and solve for K. So I will show you just how you would do that. Just if you want to go through the extra steps and you didn't recognize that, BC is going to cancel out on both sides. So first of all, I am going to do the following. I'm not going to get the decimal value of BC. Instead, I'm going to get what its square root is, the exact value. Meaning 6 squared plus BC squared equals 24 squared. So BC, if you go ahead and it's going to be 24 squared minus 6 squared, and then you square root both sides. Therefore, BC is going to be equal to the square root of, I believe it's 540. Yep. Okay. So BC is just going to be square root 540. All right, next. We need to find the measure of angle C. So the way we can do that is we can notice that the sine of C is equal to opposite over hypotenuse, 6 over 24. Therefore, C is equal to the inverse sine of 6 over 24. So I'm going to do that in Desmos. Now, we do need to make sure we are in degree mode, not radians mode. We are not in degree mode, so I'm going to click here in the wrench, click degrees. Okay, there it is. So now, if you go back to the same formula, basically I originally typed, 1/2 times BC times 6. So the area is 1/2 times square root 540 times the height, which is 6. That is equal to the area, which is also equal to k cosine c. So I'm just going to set up a regression statement and do k cosine, and then I'm going to use the c that I defined in the step above. And it solves and gets 72. So that's just an alternate way you could go through this as well if you wanted to find the actual values of BC and angle C. All right, next up, we have a circle problem. And in this one, you are given an equation. It has some constants in it. And essentially, it's asking for an expression for the radius in terms of A. So if you want to do this one by hand, what you would do is you would complete the square on x and on y. So I'm going to add 2 blanks. And then over here I have 40, and I'm going to also add 14a. All right, and then technically there's going to be 2 blanks over here as well. So completing the square, we take the b value, or the middle term, we divide it by 2. That negative 2a will then become negative a, and then you square it. And then that goes in the blank here. That's going to go in the blank here. Sorry, it would be a squared. That's what goes there. That should be a squared. All right, then for here, negative 6 divided by 2, negative 3. That b over 2 term gets squared, so I get a 9, I get a 9. Okay, the left part doesn't matter. All I want to know is what do I get on the right side for the radius? So it's a squared plus 14a plus 49. This is going to factor, okay, as a plus 7 times a plus 7, or a plus 7 quantity squared. But remember, in the standard form equation of a circle, it is x minus h squared plus y minus k squared, blah, 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 equals r squared on the right. So this is equal to r squared. Therefore, r is equal to the square root of this, which is just a plus 7. It's letter B. It is not letter D. Okay, now let's see how you could solve this in Desmos. So I am going to go to Desmos. I am going to do circle regression. So I am going to, and it's going to take a little while to type out because I got to do x1 and y1 for every term. Minus 6y1 minus 14a minus 40. So I take the original equation, I get it equal to 0. Then I'm going to do regression to the standard form. Okay. And now what I need to do is I need to define a list, an element list for x1 and y1. It's going to be much quicker if you pick a number and pick its opposites. So like I use 10 and negative 10, and then I pair them up so that I get each combination of numbers with each other. Now, Excuse me. So what I need to do is the following. I have a value for the radius. Okay, it's telling me the radius is 2.44 4 how many 2.4 yeah 2.44481. All right. So all I need to do now is I need to take the value for a that it gave me, and I see which of these answer choices equals 2.44481. So if I do a minus 7, not equal. A plus 7, yes, is equal. Notice it's 0.81 in the regression statement because of rounding, but down here you see it's technically 0.8086, 8799, blah, blah, blah. Anyways, so that's it. I mean, if you take this and square it, it's obviously not going to be 2.44481, and same thing with a minus 7 squared. So this is how you could do the problem entirely in Desmos. And just the last thing, if you want more information on doing regression of circles, check out my ultimate Desmos guide to digital SAT math. I will post the thumbnail on the screen in this video, which has the specific section of it that goes through how to do that. All right, next up, we have question number 5. So here we have an equation with two constants, some rational exponents, and we want to know what value of a would make k equal to n to the 2a plus 1. Okay, so the way to do this by hand would be to first just write out, obviously, the two things that are equal. And then we also know that k is equal to n to the 2a plus 1. Okay, so now what I'm going to do is just replace k with this n to the 2a plus 1. So we get n to the 5/3 equals n to the 2a plus 1 quantity raised to the 3/2 power, just substituting in. All right, let me just confirm what I did next. Okay, so now, because we have the same base of n, now we can just set the exponents equal. So you got 5/3 equals 2a plus 1 times 3/2. Now you can technically do this whole thing out by hand, but honestly we could just go to Desmos and do it. I think what I did is I technically multiplied by 6 just to clear the fractions and get rid of those. So on the left side, 3 goes into 6 twice. I get 10. The right side, 2 goes into 6 3 times. I made this 3 a 9. So then 9 times 2 is 18a plus 9. 18a equals 1. Divide by 18, a equals 1/18. And I should be positive. Yes, positive 1/18. Let me just double check in Desmos that the equation was solved correctly, and then after that, I will show you how to do the entire problem in Desmos. Okay, so we get this decimal 0.05555, and then it rounds it to a 6. Yep, it's 1/18, and it's positive. Okay, so that's the correct answer. That is what you would type in. Again, that or 0.0555 or 0.0556, or you could put the leading 0 and then have one less decimal after, or one less value number after the decimal point. Okay, so there's technically 5 different correct answers. All right, in Desmos, what you want to do is the following. Basically, we're going to set up a system of equations. So we have n to the 5/3, and we have k to the 3/2. Sorry, those are going to be in separate things. What am I doing here? Start a new one, end this one. Okay, put the tilde. All right, so those two things are equal. Then we also know that k is equal to n to the 2a plus 1. Close this. Okay. The problem is, notice in the question it says for n and k as positive constants greater than 1. Okay. Here it's just assigning every n to 1 and k to 1, which means that a just becomes 1. We don't want that. So I'm just going to choose a value for n of like 1.3. Okay. Now it works out. Now notice it gives me a value for a And unfortunately here, for some reason, it's not letting me like turn it into a fraction. So if you want to turn it into a fraction, you just have to retype the whole thing. And notice it's just 0 and then a bunch of 5s, and then eventually it will give you the 1/18th if you want the fraction form. But this is how you could solve the entire problem in Desmos. Basically, it's a system of equations we're solving using regression. All right, next, let's look at question number 6. So here we have 3 different objects with various speeds. And the one that we've done a ton of percentage problems before, but what makes this one a little bit unusual is that technically the answer is, first of all, the sum of the speeds of the objects, and also it's in terms of this, the speed of this object. It's in terms of like c. It's in terms of a constant down here. It's not just a straight number, for example, that you would just type in, in a fill-in question. All right, so we know that a is 7,700% the speed of object c, but its speed is actually lowercase c. Okay, so that means the speed of a is equal to 77 times c. And we know the speed of c, whoops, should use lowercase c here, is equal to 0.004%. That's going to be 0.000, and then technically, sorry, there's 2 zeros originally, and then you have the 4. But you have to divide this by 100 to turn it into a decimal, so you have to add 2 more zeros, 0, 0, the speed of object b. Which of the following expressions represents the sum of the speeds? So we're adding a plus b together here, essentially. So a we already have in terms of c, like that's fine. B we do not. So technically what we have to do is you have to divide by 0.00004 on both sides, and then that will give you that b, speed of object b, is equal to 25,000 times lowercase c, the speed of object c. So then we just add these two together, 25,000 c plus 77 c, and we get our answer 25,077 c. So the correct answer here is letter D. Now, of course, we can go to Desmos, and we can do this entire thing in Desmos as well. So, again, I'm going to set up a system of equations with regression. So the first thing is going to have, whoops, we want to make sure we want the bracket. A is equal to 7,700% of C. And I'll use a lowercase c for that one. Okay. Then, next, c, speed of object c, is 0.004% of b. Okay. Then, we want to know the speed of basically a plus b together. Okay, so now what I'm going to do for basically like the third equation here is I'm going to take a plus b, because that's what the answer choices represent, and I'm just going to say, okay, a plus b is going to be equal to, whatever, pick whatever letter you want, w, p, doesn't matter, multiplied by c. Okay, and now the problem is here, it's not giving us a good value for, it's giving us all zeros. Okay, that's not helpful, that doesn't work. Because if you notice, these answer choices are all some number times c. So really, we want to solve for this number that is being multiplied by c. Okay, so let's just make sure. Yeah, everything's typed in correctly. Okay, so let's try to define c as like whatever. Okay, pick one. You can pick any number you want. You pick 1. You can pick 2. It technically, it doesn't matter what value you pick. Notice the p, the number that's in front of the lowercase c here in the last equation, that's what we're solving for. That's the answer we're looking for in the answer choices. So notice it doesn't matter what a and b are. Technically, the p-value here, it's 25,077, whether I pick 3 or 2 or 1 or even 10. the p-value remains constant. So this just confirms, this is how you would know it's answer choice D, because you see 25,077, which is multiplied by C. All right, so now let's go to the top of the next page. Question number 7. Okay, so here you have an exponential function, and you're being told that every time you increase the x value by 4, the f of x, or y value, increases by, whatever, p%, by some value. All right, the question wants to know, okay, for all these various other functions below, which one of those shows this same increase amount when you increase the x value by only 1? Okay, so first I'll talk about the theoretical way, then I'll show you how you could actually go into Desmos and calculate it and figure it out, with, say, actual numbers. All right, so the theoretical way basically says, all right, if you're increasing x by 4, let's say x is going from 0 to 4, okay? So that means you're going from like 18, times 2.4 to the 0, which is just 18 times 1, or 18. And then 18 times 2.4 to the 4 over 2. All right? Well, 4 over 2 just divides into 2. So therefore, notice what's happening here. Basically, you have the same 18, and you're going to end, when you increase x by 4, you end up multiplying it by 2.4 squared. Okay, so what is 2.4 squared? Well, if you don't know it off the top of your head, it's just 5.76. So in other words, what's really happening is you're taking 18, you're multiplying it by 5.76 for every increase of x by 4. Okay? It doesn't matter what p% is. It doesn't, we don't actually have to calculate what the percentage increase is. All I have to know is what happens to the y value when I increase x by 4. So when x goes from, say, 0 to 4, y basically gets multiplied by, choose a different thing instead of x, by 5.76. So now, when you look at these possible answer choices, okay, when you increase x by 1, so in other words, if you go from 0 to 1, which of these is going to result in multiplying the n value by 5.76? All right, obviously it is going to be right here, letter C, which is, your correct answer. Now, let's look at some actual, if you didn't quite follow that, that's fine. Let's look at some actual numbers, and I'll show you how you could actually calculate the percentage increase, the p%, and then figure it out basically from there. Okay, so what I would do is I would go to Desmos, and I would say, all right, I have my original function here, f of x equals 18, and then I've got 2.4 to the x over 2. All right. So now, x is increasing by 4. So I'm going to find the percentage increase. In other words, I'm going to find what p is when I go from 0 to 4. So percentage increase formula would tell us do f of 4 minus f of 0, basically new minus old over old, or divided by f of 0. Okay? Then multiply that by 100 to turn it into a percentage. So in other words, the p here, like the p% increase, is 476 percent. Now, if you think about that as a decimal, of course, that's just equivalent to the number 4.76. Now, go back to exponential functions. Think about how exponential functions are set up, right? You have like the initial amount out front, and then it's like 1 plus or minus r, which is your growth rate or your decay rate if you're decreasing, and then up here you have like, whatever your exponent, which for these it's just going to be x. Okay, so we want something that will have a 476% growth rate. Okay, so that as a decimal is 4.76. That means first of all it's going to be plus, not minus, and second of all the r value is going to be 4.76. That's what you're going to plug in here. So therefore, you combine those together, you get 5.76, to the x. So that's a second way you could do this. You could think about it. Here is also a third way. Okay, will take longer, it will take more time, but still you could just do this, brute force it basically if you wanted to. All right, original function, like I already showed, increasing x by 4, p is 476%. Let's go through the answer choices and let us So I'm just going to move this up here. First of all, I'm just going to let n be whatever. I mean, we can just let it be 18. It doesn't have to be 18, but we'll just make it the same number. Okay, now what I'm going to do is calculate the percentage change when I increase x by 1. So in other words, when I go from x is equal to 0 to x is equal to 1. Okay, so increasing x by 1, what is the percent increase that I find? Notice for answer choice A, it's 140%. That does not match 476. Okay, let's check out B. It's 376%. Notice that does not match what I got for the original function, which is 476. So that's wrong. Also, you're probably noticing now that the percent increase is technically like 1 less than the number you see inside here. I mean, technically multiplied by 100, right? 476 minus 100 is 376. Okay, let's check C. 5.76. Okay, now here, increase x by 1. What's the percent change? 476. That matches the same p-value I got for the original function, increasing x by 4. That is the correct answer. Last one, just to show you that it is not correct. This one, it's increasing by what? 1,282.4%. Okay, clearly wrong. But that's a third way. That's, kind of like a third approach that you could take to solve this problem. All right, let's look next at number 8. Here we have a formula. It's asking for the value of which of these expressions is equal to the value s. So all I'm going to do, let me just look at my notes here too. Okay. I actually moved the two s terms over to the right just because of how I set up and chose the answers. Like, basically the answers are pretty much all positive on top, except for this last one, D, which has a negative. Hint, it's not going to be D. But because of that, I'm actually going to add 2QRS to the right and subtract 8RTS. Move that over to the right. And then that's just equal to 10QRT. So now if we want to solve this for s, we can just factor out the s, and we can get 2q minus 8rt. Sorry, 2qr minus 8rt. That's still equal to 10QRT divided by that entire expression to leave s alone by itself. Now, if you look at these, notice none of these have 2qr minus 8rt in the denominator. That's because there's a common factor of 2 that you can cancel out here. So divide by 2, 1. Divide by 2, 5. Divide by 2, 4. All right, so what do I get? 5qrt over qr minus 4rt. Correct answer is going to be letter C. Now, here's how you could also alternately solve this in Desmos. So, this is the general approach that'll work for any formula. First thing I'm going to do is I'm going to type the entire formula as it is given, except to make it a regression statement instead of an equation. Now, a couple things to note here. Okay, first of all, q over t has to be greater than 5. For the given values here, that is actually not true because q is -1. It's -1. -1 is not greater than 5. So we need to fix that. So I'm going to make t, I don't know, maybe 0.5. Can I do that? -0.5? Okay, but that doesn't make q... let's see, it doesn't make q greater than 5. It does still make it at least a positive value, though. Let me see if I can make it even smaller. 0.1? Not quite. 0.5. 0.1. Still ridiculously small. Okay, I might have to remove that restriction from the problem because it looks like q over t is automatically going to be is going to be capped at 4 anyway. So regardless of how small I make it, yeah, I'm still not going to be able to get it to 5. So I'm going to go ahead and edit this out of the problem. Basically, the worksheet you get will not have this in it. I don't, you don't need that technically to solve it, to go ahead and figure it out. So in any case, let's go back to this. So let's say I'll just define t as negative 1. Okay, now all we need to do is notice it chose values for q, r, and s. I need to go through the answer choices and to type each of them and see which one is going to give me a value for s of positive 1. And I'm going to start with A, and then I'm just going to edit that if it's not the correct answer. I'm not going to type all 4 out individually. Okay, so notice A gives me 2. That is wrong. Okay, it's not A. Move on to B. All right, so what do I need to change for B? So first of all, it's a 5 on top, and it also looks like it's a plus on the bottom. All right, that is not positive 1, so B is wrong. Now let's check C. You might have seen when I initially changed the 5 on top, since I had the minus from part A, it actually did display the correct answer. Yep, there it is, positive 1, so it is C. And now, of course, we could also just double check G. If I throw a minus out here, of course, it's minus 1. That does not match. It has to be positive 1. So this is how you could solve almost any, I believe, almost any formula problem in Desmos using regression. The only thing you have to be careful with is sometimes you have to define values for some of the letters if it is giving you numbers that don't meet the given conditions on the problem, or it's like just giving you all zeros or all ones. Okay? So just be aware of that. That's an extra step you might have to take. All right, let's look at number 9 now. At the bottom of this page, we have an exponential function, and we're told that for c, when you plug in c for x, that the corresponding y value is m, and then when you basically plug in c plus 1, the new y value is 75% greater than m. I have no idea why the 1 is underlined. I'll have to just grab that and fix that in the PDF file that you see. Okay, anyways, you want to find the value of b. So here's the theoretical, shortest, quickest, easiest way to solve this. Think about an xy t-chart table here, right? You plug in c, y value is m. You plug in c plus 1, so i.e. you increase the x value by 1. The new y value is 75% greater than m. So that means we take m and we add 75% of it. That's what 75% greater than means. And that just combines to give 1.75m. Okay, now, since this is an exponential function, we know that going from one y value to the next, you will multiply the previous y value by a number. Just like with a linear function, you add some value, from the previous y value to get to the new one. But for an exponential function, you multiply. So what do I multiply to get from m to 1.75m? Well, I'm just multiplying by 1.75, and that is the b value. That's your base here. The a is just, that's your starting value. So that's the answer, 1.75. You could also type it in as, I believe, 7 over 4. But let's see how you could also solve this in Desmos. So let's delete everything. So if you want to make a table, okay, you make a table here, C and M, and you have and C, and this is, this would be C plus 1. And then this is 75% greater than m. I don't think, you can't type it in like that, so you do have to know that it's m plus 0.75m. Okay. Now what you're going to do is you're going to add some constants. So let's say c is like whatever. 2. M. You have to add a constant. It doesn't matter what value you pick. Let's just pick 1. Okay. Now we're going to do the regression statement. A, b to the x1. Okay. So notice, you have to pick values for c and m here. It won't work if you don't actually do that. B is 1.75, a is this number. What's going to happen as I move m and c is that the a value will change, but the b value will not. It will stay fixed at 1.75. So notice, as I move this, a gets bigger. So I go the other direction, a gets smaller, eventually it flips negative. But b never changes. Same thing with c. As I move this, a value actually gets smaller. As I move this way, A value gets bigger, but the B value never changes. So that's how you could solve this problem entirely in Desmos. All right, let's look at this last question here. Problem number 10 on this October 2025 SAT official test problem, worksheet number 1. So this is a factoring question. They give you this fourth degree polynomial. They tell you it's equivalent to this factored form where j and n and p and k are integers. And then they want to know which of the following cannot be an integer. Okay? So in other words, which of the following must be a decimal, essentially. All right. So first thing I would notice is that there is something out here in front, right? This is a common factor. So this has to be, the only number that is possible for j is 2, because you have a 3 inside here already. So if you like FOIL this out, this times this would be 3x to the 4th. So the only thing you can have out front here is j to make 6x to the 4th, and the original expression is a 2. Okay, so right off the bat, I know that j has to equal 2. All right. So now I also know it's going to look something like this: x squared plus n. Okay, 3x squared plus n, x squared plus k. So this is not necessarily the quickest or easiest way, but I'm just going to show it to you. Just basically, it's like trial and error. So when I was going through this, I basically made a little table, and I put j, and I put n, and I put k, and then I put p. Sorry, I put p over 2, and I'll explain what that is in a second, and then lastly, I put p. Okay, so essentially what is happening here is I'm going to run through all the different possible factorizations that you could have. How many different things do I need? 1, 2, 3, 4. It looks like I need a total of 6. Okay. So one other thing just before we begin. If you pull a 2 out initially as a GCF, you're going to have 2 and then 3x to the 4th plus, and notice the p would get divided by 2, x squared, and then plus 63. Okay? So this is what's being factored into the 3x squared, x squared, nk. So first of all, okay, so now I can fill in the table. J is 2 always. N and k are going to alternate as different possible factors of 63. So n could be 7, which would make k 9, or n could be 9, which would make k 7. N could be 21, which would make k 3, and n could be 3, which would make k 21. The opposite, just switching the numbers. N could be 63, which would make k 1. N could be 1, which would make k 63. Okay. Now, basically what I'm going to do is, notice to get the p over 2 value, like, in here. Technically, I'm doing FOIL, but I'm really only doing the inner and the outer terms. So this formula is really, it's like n times 1 plus k times 3. Or it's really n plus 3k, if you think about the FOIL, right? And this you could just automate in Desmos if you wanted to. But I'll just do it here, and I'll just tell you, basically what the numbers are. So n plus 3k. 7 plus 3 times 9. 7 plus 27, 34. Next, it's going to be the opposite. So it's going to be 9 plus 3 times 7. 9 plus 21, 30. Then we're going to do 21 plus 3 times 3, or 21 plus 9. It's also 30. Then we're going to do 3 plus 3 times 21, which is 3 plus 63, 66. And lastly, 63 plus 3 times 1, which is also 66. And then 1 plus 3 times 63. That is 1 plus 189, which is 190. So these are all the values, basically, that you would get for this term. But in the original equation, you have to multiply these by 2, because we factored a 2 out. So really P here is 68, 60, 60, 132, 132, and 380. Okay, so which of these cannot be an integer? So when you run down these, you're looking for like, whatever over whatever. Can you make an integer in any of the rows? So A, n over j, okay? Odd over even. 7 over 2, integer. No. 9 over 2, no. 20 over 2. Notice they're all decimals. 3 odd over even, no. Odd over even, no. Odd over even, no. So that is the correct answer. But just to show you, n over k. All right, 7 over 9, integer, no. 9 over 7, no. 21 over 3, yes. 21 over 3 is 7. It can be an integer. Therefore, it is not the correct answer. Let's look at p over j. J is 2, so you only have to find one value of p that divides by 2. Well, all of them divide by 2, because 68, 60, 132, 380. So therefore, that one's out. K over n, you can just use now the exact same process that I was doing before, just now make k 21 and n 3. 21 over 3, 7. Yes, can be an integer. Therefore, correct answer for this one is letter A, n over j. Now, let's take a look at how you can use Desmos to help solve this problem. I'm not aware of any way that you can use Desmos entirely, because this is, again, kind of like a process of elimination, eliminate 3 of the 4 wrong answers type problem. But you can use it to speed up some of these basic calculations. So we go to Desmos. Basically, I am going to first type in the original expression, okay? And then after that, I'm going to do regression. I'm going to set it equal to the expression with the n and k, the factored form of it. Make this a 1. Okay. So now, of course, I need to add an element list for x1. Okay. So notice it is already picking up the correct value for k here. Or not, excuse me. It's picking up the correct value for j, okay, of 2, of the common factor that you factor out. However, it's giving me these random decimals for the other letters, basically for p, n, and k. So the problem is, how do I force it to give me integer values? Because that's what we want. You know what I'm saying? Like when we're doing this factoring, we want all these numbers to be integers. So essentially what I'm going to have to do is, and again, this is where Desmos at least will not solve the entire problem for you, I'm going to have to pick a value for n. So what you do have to notice, what you do have to be aware of is that, okay, if j is 2, that means you're factoring out a 2. That means n and k are going to have to be factors of 126 over 2, or in other words, of 63. So you're going to have to try different factors of 63 to see what happens. So let's start with just saying n equal to 7. Notice when I do that, it now gives me k is 9 and everything else is a nice integer. So, okay, it's working correctly so far. However, now I'm going to type in the various answer choices, and I'm going to see which ones are integers and which ones are not. Again, we're looking for the one that cannot be an integer value. So if we find an integer for one of these expressions, just one integer, then we eliminate that as an answer choice, and we basically move on and look at the rest. Okay, so notice here I have n over j, not an integer, keep it. N over k, not an integer, keep it. P over j is an integer, get rid of it. K over n, not an integer, keep it. So right now I've only been able to eliminate c. So now we'll go back to Desmos, and I will try instead the opposite of 7, which was 9. Basically, I'm switching n and k. All right. This, again, c I can eliminate, so let's just get rid of that. So now we're down to a, b, and d. All right, these all three are not integers. All right, we need a different pair of factors of 63. So instead of 7 and 9, let's just try 1. Let's just see what happens. Okay, 1 and 63. All right, so a and b, still not integers, have to keep them. D is an integer. Let's get rid of it. All right, so now we're down to 2 that we have to check. Let's just try 63. Okay, notice when I do that, B gives me an integer value, therefore we can eliminate it. So by process of elimination, I've determined that the only one that basically cannot be an integer is going to be answer choice A. So that's how you can use Desmos to solve this problem. Again, probably quicker than like what I did here, where I went through and made the table and wrote out all the different, possible values for n and k and for p and for p over 2, and then went through each one and said, okay, which is an integer, what's not an integer. So if you want to use Desmos for this, perfectly understandable. Can cut down on the work, cut down on the time. Just be aware, you still do have to recognize. I mean, technically, it will get j for you. It will tell you that j is 2. But you still have to recognize that n and k are going to be factors of 126 over 2 or of 63. So you still have to know to check for n or for k, whichever one you pick. You're going to have to put in factors of 63 to go through and check each of the answer choices and see which ones can be an integer versus which ones are always not going to be an integer. All right. I hope you enjoyed these 10 questions, that I compiled from the October 2025 SAT math exam. If you did, please do give this video a thumbs up, subscribe to my channel, and sign up for notifications. If you have any questions or comments or alternate solution methods or other October problems that aren't featured in this video or in the other ones, feel free to leave them in the comments section below. Otherwise, like I said, there's a link to the PDF file, which has all these problems in both the description of the video and also in the pinned comment as well. Make sure you check out video number 2, which will have 10 more new problems, and then also video number 3, which will cover essentially a bunch of review problems that I've already solved, a lot of them in multiple instances. And lastly, if you're looking to improve your knowledge of Desmos, please do check out my Ultimate Desmos Guide to Digital SAT Math. It's up to over 5.5 hours of tips and tricks and 65 practice problems to help you ace the digital SAT math section.